Welcome student. How are you? Your study is going on properly? Today I will discuss yet another topics in climatology. The topic is very relevant. It is atmospheric humidity, cloud formation, precipitation, etc. Getting well now? I had said that there are three factors affecting the atmospheric condition. One factor is temperature, second is pressure, and third one is humidity. Humidity is defined as the moisture content of the air. Okay? And I have already stated that the term atmosphere itself was derived from the term atoms, means water droplet. Getting well now? Now see, as far as the question of atmospheric humidity is concerned, so how atmospheric humidity will be defined? So I said that amount of water present in the air is referred to as atmospheric humidity. And as far as the question of humidity content of the air is concerned, so you see, it is said that moisture retaining capacity of air is proportional to temperature. Getting well now? Moisture retaining capacity, जल धारण करने की क्षमता. Okay? So the moisture retaining capacity of the air is proportional to temperature. It refers that if the temperature is 1 degree Celsius, it possesses the capacity to hold 1 liter of water. If temperature is 2 degrees Celsius, then 2 liter of water. 3 degrees Celsius, then 3 liter of water. 10 degrees Celsius, then 10 liter water. 20 degrees Celsius, then 20 liter water. Getting well now? So this is the way. But the moisture retaining capacity is proportional to temperature. More will be the temperature, the air will have high moisture retaining capacity and vice versa. Getting well now? Now see, actual amount of water present in two factors. Temperature is one factor, and temperature determine, right, what is the capacity of air, to hold the moisture. Getting well now? But at the same time, you see, if the air is having the capacity, but water sources are not available. In this case, despite the fact that the air possesses high moisture retaining capacity, it will remain dry, that is moistureless. Getting well now? As for example, you see in Thar Desert, in Sahara Desert, though temperature is very high, so in this case, moisture retaining capacity of the air is more. But since sources of water is almost absent there, the air remain dry. Getting well? Now see, it means particularly the actual amount of water depends on the two factors. One is particularly temperature, and second is particularly sources of water. You see, it means if temperature is very less, then if sources of water is present, despite of this fact, the air will not hold humidity enough. So temperature is limiting factor in polar zone. On the other hand, resources of water in the desert area is the limiting factor. Getting well now? Now see, as far as the question of moisture content of the air is concerned, there are several ways to express the moisture content of the air. Right? Actually, you see, first is absolute humidity. Absolute humidity. Second is specific humidity, and third one is relative humidity. There are three ways to express the water content of the air. One is referred to as absolute humidity, second is specific humidity, and third one is relative humidity. We are mainly concerned here with absolute humidity as well as particularly relative humidity. Getting well now? Now, one should clarify what is the meaning of absolute, what is the basic concept of absolute humidity and what is the basic concept of relative humidity. So, as far as the question of absolute humidity is concerned, so absolute humidity is defined as the actual amount of water present in the air. Okay? What is absolute humidity? It is clear? It is defined as the actual amount of water present in the air. Suppose this is 1 unit of air and its temperature is 10 degrees Celsius and it contains 5 liters of water. Getting well now? Right? So this 5 liter water is actual amount of water present in this air now. So this 5 liter will be referred to as absolute humidity. Getting well? You see, if you will increase the temperature of the air, then suppose particularly the temperature will be reduced to 5 degrees Celsius, right? In this case also the air will contain 5 liter of water, okay? And if you will increase the temperature of this part of the air, right, up to 20 degrees Celsius, despite of this fact it will contain 5 liter of water, it is obvious that absolute humidity is defined as the actual amount of water present in the air and it remain unchanged with the alteration, that is variation in the temperature, right? Because in case of particularly you see, we have 3 examples, A, B and C, right? In case of B, there occurred reduction in the temperature, okay? Initially it was having 5 liter of water and now it is having particularly, it is also having 5 liter water, right? Though temperature decreased but absolute humidity remained the same, okay? On the other hand, you see when the temperature will increase from 10 degree to 20 degree, right? Despite of this factor, the 5 liter of water is the actual amount of water present in the air now. So that's why it is said that absolute humidity not varies with the change in the temperature. Getting well now? Again, you see the second important aspect to discuss relevant here is the relative humidity. Okay, you see, I said that absolute humidity is the actual amount of water present in the air, right? Actual amount of water present in the air is defined as the absolute humidity. What is the meaning of absolute humidity? It is clear now. It is defined as the actual amount of water present in the air. Getting well? Now see, as far as the question of relative humidity is concerned, so relative humidity is defined as, you see, I am expressing in mathematical term, right, in the form of formula, then the matter will be more clear, right? Relative humidity is equal to actual amount of water present in the air, present in the air, getting well? Actual amount of water present in the air upon water required to saturate air, getting well now, into 100. It is clear now? So this is the mathematical formula of relative humidity. So relative humidity is expressed as the actual amount of present in the air, actual amount of water present in the air upon water required to saturate the air into 100. Okay? So this is the mathematical expression of relative humidity. Getting well now? Now see, as far as the question of relation between relative humidity and absolute humidity is concerned, so actual amount of water present in the air is referred to as absolute humidity. So you can modify the formula in the form that relative humidity is equal to absolute humidity upon the water required to saturate the air into 100. Getting well now? Now see, as I said, as I have already said, that the moisture retaining capacity of the air is proportional to temperature. It means at 1 degree, 1 liter water, at 2 degrees Celsius, 2 liter water, at 3 degrees Celsius, 3 liter water, at 10 degrees Celsius, 10 liter water, at 20 degrees Celsius, it will contain 20 liter of water. It means since moisture retaining capacity is proportional to temperature, that's why the amount of water or moisture retaining capacity gradually increases with increasing temperature. Getting well? Now see, suppose probably this is the air which is held at the temperature of suppose 10 degrees Celsius. 10 degrees Celsius is the temperature of this air. Getting well? Or suppose 20 degrees Celsius is the temperature of the air. Okay, 20 degrees Celsius is the temperature of this mass of air. Okay, 20 degrees Celsius, and it contains 10 liter water. Getting well now? It means absolute humidity is 10 unit. Okay, right? suppose you will decrease the temperature of this air and the temperature of this air will be reduced to 10 degrees Celsius, right? And it contains 10 liters of water. Or you see, if you will increase the temperature of this air and the temperature of this air will be increased to 40 degrees Celsius and hence it contains 10 liter water. We have three conditions, A, B, C. Getting well now? We have three conditions, A, B and C. Actually now I am calculating the relative humidity, right, of the three component. Okay. You see I am calculating the relative humidity of, right, actually it will be better to identify it as, you see this is A, this is B and this is C1. Okay. I am calculating the relative humidity of A. Okay. So relative humidity is equal to actual amount of water present in the air. So this actual amount of water is 10 upon water required to saturate the air. It means you see at 20 degrees Celsius, since the temperature is proportional to moisture retaining capacity, at 20 degrees Celsius it poses the capacity to maintain 20 liters of water. So it means 10 upon 20, right? Because at 20 degrees Celsius it will get saturated now, right? Into 100. Okay? So this is 5 and this is 50%. So actually relative humidity of A is 50%. Getting well? Again you see I am calculating the relative humidity of B. So relative humidity of B is equal to 10 upon 10, because at 10 degrees Celsius it possesses the capacity to hold 10 liter water, into 100. It is 100%. Getting well now? Relative humidity is 100%. Okay. Here relative humidity is 100%. Here relative humidity is 50%. And I am calculating the relative humidity of C. Here relative humidity is equal to 10 upon 40 into 100. Okay. 10 upon 40 into 100 is equal to 25%. Get it now? So we have three conditions, A, B and C. In case of A, the relative humidity is 50%, and when we decrease the temperature, right, of the air from 20 degrees Celsius to 10 degrees Celsius, there occurred increase in the relative humidity. Getting well now? On the other hand, when the temperature of the air is increased by and from 20 degree to 40 degree, the relative humidity decreased, right? It means it directly refers that, right, relative humidity is inversely proportional to temperature. More will be the temperature, less will be the relative humidity, and less will be the temperature, more will be the relative humidity. Getting well now? Actually, you see, it means if relative humidity is the indicator of saturation of the air, na? So if you will increase the temperature, then the air will tend towards saturation, right? We are towards unsaturation. But if you will decrease the temperature, it will tend towards saturation. So what is the actual position of relative humidity? It is clear. We have three positions, A, B and C. In case of A, right, the relative humidity is 50%. If you will decrease the temperature, then relative humidity increases, right? And as was seen in this case, and if you will increase the temperature, then relative humidity get decreased. Okay, so it means on this basis one can conclude that relative humidity is inversely proportional to temperature. More will be the temperature, less will be the relative humidity. Okay, and vice versa. It means if you will increase the temperature, the degree of unsaturation increases, and if you will increase the temperature, the degree of unsaturation will increase, and if you will decrease the temperature, the degree of saturation will gradually increase. Okay. Now see, as far as the question of relative humidity is concerned, okay, relative humidity is concerned or absolute humidity is concerned. Getting well now? So you see, as far as the question of relative humidity is concerned, right, how it will be defined, you see. देखिए, actually, you see, when you will decrease the temperature, it is clear now? then relative humidity है ना, with decrease in temperature relative humidity increases. Okay, if relative humidity is equal to 100%, right, it refers that the air is saturated. Okay, if relative humidity is less than 100%, okay, it reveals that the air is unsaturated, and if relative humidity is greater than 100, then the air is supersaturated. So we have three conditions. In first condition, relative humidity is 100%. So 100% relative humidity indicates that the air gets saturated. Okay, right? If relative humidity is less than 100%, then it indicates the unsaturated condition of the air. And if relative humidity is more than 100%, then, right, it indicates that air is supersaturated. Getting well now? You see, you must keep in mind one important point. The temperature at which the relative humidity is 100%. Okay, the temperature at which the relative humidity is 100% is referred to as dew point. What is the meaning of dew point? It is clear now? Dew point is the temperature at which the relative humidity is 100% now. If you see, right, the dew point temperature, right, what is the meaning of dew point temperature? It means for dew point temperature indicate that the relative humidity is particularly is 100%. So what is the basic concept? Getting well now? Now see, as far as the question of existence of water in the air is concerned, so if relative humidity is less than 100%, in this case the water will remain in the form of water vapor. Getting well now? But if relative humidity is more than 100%, then up to 100%, suppose probably the temperature is 10 degrees Celsius, the temperature of the air is 10 degrees Celsius, suppose it at 10 degrees Celsius it is having the capacity to hold 10 liter of water, no? And if water is 15 liter, okay, then 5 additional liter of water is present there. So this 5 liter of water will get converted into water droplet. Getting well now? Right? So the conversion of water vapor into water droplet or ice crystal, because conversion of water vapor or water vapor into water droplet or ice crystal depend on the temperature of the dew point. If temperature of dew point is less than 0 degrees Celsius, right, less than 0 degrees Celsius, okay, in this case water vapor will convert into ice crystal, okay, and if it is more than 0 degrees Celsius, then water vapor will convert into water droplet. Getting well now? Right? If temperature is less than 0 degrees Celsius, then water vapor will convert into ice crystal. But if water temperature is more than 0 degrees Celsius, then water vapor will convert into water droplet. Getting well now? So conversion of water vapor either into water droplet or ice crystal is referred to as condensation. What is the meaning of condensation? It is clear now? So condensation, if occur at the temperature more than 0 degrees Celsius, then water vapor convert into water droplet. This is simply referred to as condensation process. But if the dew point temperature is less than 0 degrees Celsius, then water vapor directly convert into ice crystal. If any gas convert into solid or solid directly convert into gas, then the process is referred to as sublimation process. So in this case, condensation is going through condensation process. Condensation through sublimation process is the prevailing phenomena in this case. Getting well? Now see, as far as the question of condensation is concerned, so there are particularly three factors, okay, responsible, which is considered ideal for condensation to occur. The first condition is relative humidity should be 100%. Okay, this is particularly first condition for condensation to occur. Second is dust particles should be present because dust particle act as hydroscopic nuclei. Okay, जलग्राही नाभि के रूप में काम करता है, right? And third condition for condensation is there should be adiabatic cooling of है ना, adiabatic cooling. There should be adiabatic cooling of air. Okay, there actually the three condition is considered most ideal for condensation to occur. First is the relative humidity should be 100%. This is first condition. Second condition is dust particles should be present. And third condition is there should be adiabatic cooling of air, because you know that cooling of the air, right, or reduction in temperature causes the wind to tend towards saturation. Na? Okay, and if you will increase the temperature, then the air will become saturated and unsaturated and no condensation will occur. Getting well? Now? So actually these are the three conditions. One is relative humidity is 100%. Second is dust particle is present, and third is adiabatic cooling should occur. Okay. Actually you see if the question will be कि whether particularly without dust particle, in the absence of dust particle, condensation is possible or not. This is important question. Na? कि whether in the absence of the dust particle, condensation is possible or not. Getting well? So you must keep in mind one important point, कि actually if dust particle is not present, then even condensation is possible, but for this the relative humidity should be at least 330%. Okay, it is clear now, right? At least 330% should be the relative humidity. Then in the absence of the dust particle, condensation will proceed. Getting well now, right? It means suppose particularly this air is at 10 degrees Celsius temperature and it contains 10 degrees of water. Getting well now? So without the presence of dust particle, right, if the air is at 10 degrees Celsius, it should contain at least 33 liters of water, then only condensation will proceed. Getting well? So what is the actual position? It is clear now, right? So if in prelim the question will be whether particularly without the presence of dust particle condensation is possible, certainly yes, but for this the criteria is the relative humidity should be at least 330%. Okay. On the other hand, if in place of dust particles, salt particles are present. Salt particles are present. In this case, condensation is possible if relative humidity range between 70 to 80%, because salt particle act as better hydroscopic nuclei. Getting well now? Right? So in absence of if relative humidity is not 100%, then even particularly condensation is possible, but for this salt particles should be present is the essential criteria. Getting well now? Now see, what is the meaning, what are the criteria for, what are the essential conditions for, ideal conditions for condensation to occur? Relative humidity should be 100%, dust particles should be present, and there should be adiabatic cooling of the air. Right? Now, the term adiabatic cooling, very important aspect. Okay? What is the meaning of adiabatic cooling? It should be clarified. Okay? So you see, as far as the question of temperature change is concerned, so there are two mechanisms of temperature change. Okay? You see, if this is our surface and this is 1 unit of air, okay, and it is at 20 degrees Celsius, it is clear? It is at 20 degrees Celsius, okay, and suppose particularly it contains 10 liters of water. Getting well? 10 liters of water. Okay? So if the air move horizontally, if the air blow horizontally, this may be the condition. Or if the air move vertically, this is vertical condition, this is horizontal condition. Okay? So if temperature change occur due to horizontal movement of the air, then it is referred to as diabatic temperature change. DIABETIC diabatic temperature change. Getting well now? If temperature change is due to horizontal movement of the air, then it is referred to as diabatic temperature change. Getting well now? But if temperature change occurs due to vertical movement of the air, then it is referred to as adiabatic temperature change. Adiabatic temperature change. Getting well now? What is the basic difference between diabatic, the broad difference between diabatic temperature change or adiabatic temperature change? It is clear. If temperature change will be due to horizontal movement of the air, then it is referred to as diabatic temperature change. And if it is due to vertical movement of the air, then it is referred to as adiabatic temperature change. Now I am explaining it in more detail. Okay? You see, if while moving in this direction, if this component of the air mixes with the air at having 10 degrees Celsius temperature, getting well now? In this case, when this air will get mixed with this air, which is at 10 degrees Celsius temperature, then the temperature of this wind will reduce to 15 degrees Celsius, the average temperature. It is clear now, right? So this indicates the diabatic cooling process, diabatic cooling process. Getting well now? So it means if the air while moving horizontally mixes with the air having less temperature, then there occur reduction in temperature, and this temperature change is referred to as diabatic cooling process. Getting well? On the other hand, if the air is moving in this direction and it mixes with the air which is at 40 degrees Celsius, okay, whose temperature is 40 degrees Celsius, so as a result of mixing, its temperature will increase to 30 degrees Celsius. Getting well? Its temperature will increase to 30 degrees Celsius. So this 30 degrees Celsius is the increase from this temperature condition. So this is referred to diabatic heating process. What is the basic difference between diabatic cooling and diabatic particularly heating? So it means there are two processes involved in the diabatic process. One is the cooling of the air and second is the heating of the air. If air mixes with the air having less temperature, then there occur reduction in the temperature of the air, and this is referred to as diabatic cooling process. On the other hand, if the air mixes with the air having high temperature, then there occur increase in the temperature of the air, and this is referred to as diabatic heating process. Getting well now? You must keep in mind that while moving horizontally, right, that if the wind mixes with the adjoining air, it means particularly in diabatic temperature change, the air acts as an open system. It is clear na? Open system. Okay? So you can define that if temperature change of the air occurs due to mixing of the air, then it is referred to diabatic temperature change. If temperature increases, then diabatic heating, and if there occur reduction in temperature, then it is referred to diabatic cooling. So what is the meaning of diabatic process? It is clear now. One is diabatic cooling and second is diabatic heating, and in this process the air behave like open system as its temperature change occur due to mixing of the air with the adjoining air. Getting well now? Again you see, so we have two particular example of diabatic process, diabatic temperature change. One is diabatic heating, and second is diabatic particularly cooling process. Getting well now? Right? X is the example of diabatic heating process, diabatic cooling process, okay, and Y is the example, and Y is the example of diabatic, and Y is the example of diabatic particularly heating process, because the temperature increased from 20 to 30 here. In this case, the temperature decreased from 20 degree to 10 degrees Celsius. So what is diabatic process? Getting well? One is diabatic cooling and second is diabatic heating. Getting well now? Now see, it is obvious that it is due to the horizontal movement of the air. On the other hand, the second process is adiabatic temperature change. So it is obvious that adiabatic temperature change is due to vertical movement of the air. Okay, is due to vertical movement of the air. This figure is almost clear now. Due to vertical movement of the air. You see, as far as the question of vertical movement of the air is concerned, so you see, vertical movement of the air is concerned, so if the air uplift, either upliftment of the air occur or descent of the air occur. Okay, vertical upliftment, vertical descent of the air. Getting well now? So actually you see, as far as the question of upliftment of the air is concerned, if temperature change will be due to vertical movement, then it is referred to as adiabatic temperature change. Okay, see, if the air will uplift, whenever the air uplift, okay, first particularly you understand simply, then I will explain it technically. If the air will uplift, then there occur reduction in the temperature, and this process is referred to as adiabatic cooling process. Getting well now? Right? On the other hand, when there will be descent of the air, then heating of the air will occur, and this is referred to as adiabatic heating process. Adiabatic heating process. Okay, so there are two particularly mechanisms. One is adiabatic cooling process, and second is adiabatic heating process. Getting well now? These two processes are involved. One is adiabatic heating, and second is adiabatic cooling. It is clear whenever there will be upliftment of the air will cool down. What is the reason? I will explain later. Okay, and whenever there will be descent of the air, right, with downward movement of the air, then there will be heating, and this is referred to as adiabatic heating process. Getting well now? Now, as far as the question of adiabatic cooling process is concerned, you must keep in mind one important thing. Unlike diabatic process, in adiabatic process, the air not mixes with the adjoining air, and hence in adiabatic temperature change, right, the air behaves like a closed system. Getting well now? In diabatic temperature change, it was behaving like an open system, as it was easily mixing with the adjoining air. But in this process, that is in adiabatic temperature change, the air not mixes with the adjoining air. Getting well now? The air not mixes with the adjoining air. So what is the basic difference between adiabatic temperature change and diabatic temperature change? It is clear. In diabatic, it acts as an open system, and in adiabatic, it acts as a closed system, not mixed with the adjoining air. Getting well now? Now see, as far as the question of upliftment of the air, so there are two particularly way of upliftment of the air. Okay, one important aspect is, since it is closed system, okay, so if you will apply the law of the thermodynamics, first law of thermodynamics, it is said that if Q amount of energy is supplied to the gaseous system, a part of this energy will be utilized in increasing the internal energy of the system, and remaining part will be utilized in increasing the performance of the work. This is mathematical expression of first law of thermodynamics. What is the first law of thermodynamics? You see, if Q amount of energy is supplied to the system, a part of the energy will be consumed in increasing the internal energy of the system, and the remaining part of energy will be utilized in for the performance of the work by this gaseous system. Okay, this is mathematical expression of first law of thermodynamics. Getting well now? I said that in adiabatic, if the air uplift, it not mixes with the adjoining air, and hence it acts as a open closed system. Okay, and in closed system, you know that Q is equal to 0, because if the system not interact with the surrounding, not exchange the energy as well as matter with the surrounding, then only it is referred to as closed system. So in closed system, del Q is equal to 0. It means, you see, right? 0 is equal to del E plus W, or W is equal to minus del E. Getting well now? W is equal to minus del E. It means, you see, if the air uplift, okay, the air uplift na, so air will have to work against the gravitational pull of the earth, because gravitational pull is pulling it towards the center now. Okay, the air will have to work against the gravitational pull of the earth, and this work will be performed at the cost of its own internal energy. That's why reduction in the temperature with increase in height will be recorded. Getting well now? Right? It is clear. Actually, again I am repeating, in adiabatic temperature change, the air, we have like closed system, it not mixed with the adjoining air. I written the first law of thermodynamics, that is, if Q amount of energy is supplied to a gaseous system, a part of this energy is utilized in increasing the internal energy of the system, and the remaining energy is utilized in the performance of the work. Okay? As in this case, the air act as a closed system. That's why Q is equal to 0. So 0 is equal to del E plus W, or W is equal to minus del E. It means particularly if the air uplift, it has to work against the gravitational pull of the earth, and this work is performed at the cost of its own internal energy. Getting well? So that's why there occur reduction in the temperature of the air, right? And hence the air cool down when air uplifts in upward direction. Getting well now? Again, you see, second explanation is, you know that in lower part of Earth's atmosphere the pressure is high. Okay? So when the air uplift, okay, when the air uplift, you see, first you understand, what happened with the air when it uplift, right? So in lower part the pressure is high. So that's why particularly it remains in compressed form. But as you will increase in height, it had an expansion of the air occur. The air expands. Getting well? As it moves in upward direction, expansion of the air occur. Getting well? Expansion. And expansion causes a reduction in the temperature, na? Right? Right? It is clear. In adiabatic cooling process is also, you can say, in adiabatic cooling process, the temperature reduction is due to expansion of the air. Getting well now? On the other hand, you see, when the air descends in downward direction, in upper part its volume is more because pressure is less now. But as it enters in the lower part, now it gets condensed now. It is clear now? So in this case, the particle will collide and hence temperature will increase. So this is here temperature increase due to compression of the air, and here temperature decrease